Okay, so welcome to our lesson today. Today we are going to talk about how to solve rational equations, just because we are kind of done with learning about how to simplify rational expressions. We are going to use those techniques and those methods and implement them into solving rational equations. I will like to start off with an announcement like I did last day we met. TC STEM, we have started doing tutoring. So we do math on Mondays and Tuesdays from 3 to 3:30, and we do science from Wednesdays to Thursdays, 3 to 3:30. The information about the Zoom code that is actually given on our website. So please use that kind of help to show up or to ask any kind of questions if you have anything, and drop by our tutoring sessions. All right, so for you do now in here, I am asking you guys to simplify 1, 2, 3, 4 of these rational expressions. These are not equations yet because they don't have an equal sign in them. We're going to talk about that in a later time, but for now, you have to simplify these rational expressions. So in our last, so what we usually do on the do now is we start off our lesson using something that we did last time. So this should have been a review for you guys based on the fact that we already worked on how to simplify rational expressions that are being subtracted from each other last day we met. So last Saturday, we actually talked about how to subtract rational expressions and then how to kind of simplify it that way. So now I actually want you guys to work on these 4 problems on the screen and then private message me the answer. I'll give you guys, but I know these are not obviously the easiest problems that we have been using, for which I'm going to give you guys about, take it, 8 to 9 minutes, or probably 10 minutes to work on these 4 problems. So remember, the key to solving rational expression is to have the same denominator. If you are already given the same denominator, bingo, you don't have to do much of the work. Just kind of combine the top or the numerator, simplify, that's it, that's your answer. But if you do not have the same denominator, make sure that you take the common denominator, you multiply all the denominators with that to have the same denominators for all of your fraction, and then you can simplify your tops. So please make sure that if you already see it, so for the first one, you already have the same denominator, so you don't have to do much for the first one. But then please make sure that you work your way through the second and the third, the fourth one by having the same denominator for all of them. Yeah, that is correct. I mean, yeah, that is correct for the first one. If you are stuck, if you're confused, if you do not remember how to do the steps, please let me know or let Meharin know, and we will help you guys to do those problems. So if you're stuck, if you have no clue what to do next, please let us know. And do not just skip a question and move to the next one just because you don't know how to work the first problem through. Ask me how to do the first problem and then move on. If you're stuck, then please let me know again. That is correct for the second one, Amina. Good job. Maggie, I haven't gotten any responses from you, so I just wanted to know if you are doing okay, if you are still working and you know what you should be doing next, and also you know that what you are doing now. If not, I can obviously help you.
Yeah, I was just gonna send everything all at once.
Oh, sure. Right. Okay. The third and the fourth one, they're kind of like, I would say they're relatively harder than the first two. Especially the last one, that's probably the hardest problem among the four that I gave you guys for practice. But remember, it's the same thing. Doesn't matter if you are like, if you are subtracting and adding fractions at the same time, it does not matter. It's the same thing. As long as you have the same denominator, whatever you have, just bring those down with the same signs. Just keep the sign consistent, and then just bring your numerator down, simplify, combine, and then you have your answer. For the first one, you were super close to the correct answer, actually. And I know what you did wrong, because that is so tempting to do and to make that mistake. So you were super close to the answer, Maggie, and then you obviously did it correct, but there was a slight mistake that happened, for which I'm actually gonna actually show you how to do the first problem. So this was our first problem in here, and we have the same denominator. What else can we even ask for, right? So we're given the same denominators. So then if we have the same denominators, we write them down. And then since we have the same denominator, we just bring the whatever we have in our numerators, we just bring them down. So, but then the problem in here is the fact that it's a minus, and then after that we have a binomial. So what I'm gonna do is that I'll try to like encapsulate the binomial with parentheses. And now that I did that, because always remember, guys, if you have a subtraction sign and if you have a polynomial right after it, always try to put a parenthesis while you are trying to put the subtraction sign adjacent to it, okay? Because if you do that, it's gonna make it easier for you to understand and follow along. So what I'm talking about is that when you do that, then you know that there's a negative one in there, which is what you're supposed to distribute, right?
So if it was a monomial, then we shouldn't have to change the sign, right?
If it was a plus sign, or if the numerators were, or if the fractions were being added, you wouldn't have to change the sign. The only time the sign changes is when you are like doing subtraction, or when you are like, when you
after the subtraction, if there is a monomial, then
if it's a monomial, yeah, you don't have to change it, because it's the same thing. So like me telling you this or this is the same thing, right? So you wouldn't have to change it, because they would never give you a fraction with a numerator like this. They'd always give you a numerator like that. Then in that case, you don't have to change the sign, okay?
Yeah, got
so
it.
Then you distribute the negative one. So it's negative y, and negative 1 times negative 1 gives you positive 1. Right, that was actually kind of like the tricky part. I mean, if you could see it right away, you don't even have to like do this stuff. Like you can like jump from here to like directly here. If you see that you have a negative sign, which is what you are supposed to distribute, then you don't even have to do this step where you put the parentheses around the binomial. You can skip that. But then it's always, it's better to be safe than sorry, kind of. So then you put the parentheses around your binomial, so you know that you have to distribute the negative 1 into each of the terms. Once you do that, you bring your denominator down, and once you do that, you simplify your top. And when you're simplifying, you ask yourself, what are the like terms? 5y, and you have negative y. They're placed right after each other. So 5y minus y, that is 4y and plus 1 and x plus y. I mean, yeah, x plus 4. So that is your answer. This fraction cannot be simplified any further. So whatever you have in that is your answer. Notice how we work with two different variables. Okay, so that was the first problem. So let's go back. Try the, I think that was the answer to the third question. Try the third one more time. I mean, no.
Okay.
For the second one, Maggie, so, okay, so for the second one, you were supposed to, the way that you were supposed to do the second one is, you were supposed to factor the denominator first, because you can, just by looking at the denominator right now in the form of a trinomial, you cannot figure out the common denominator. Because remember, for you to have the same denominator, you have to figure out common denominators and you have to multiply the denominators using that, right? But looking at this one, I can't, like, okay, I can tell that if you multiply this one using this trinomial, it probably will create like a common denominator, but then that is just going to make the denominators more complex. So when you have something like, yeah, that is correct, Amina, for the third one. So when you have something like this, what you try to do is that you factor the denominator first, because then the common denominators are like the same parts that you have in the denominator that will be more noticeable for you, and then you will be able to distinguish what you should be multiplying each of your denominators with to get the common denominator. What am I even talking about? Okay, so this was your problem, right? So what I told you was that I told you to factor the bottom first. And how do you factor a trinomial? What kind of factoring method among all the methods we learned do you use to factor that? So the method that you use is nothing but trinomial factoring, because it is a trinomial. So you ask yourself that what should the two numbers be that if I add them, they'll add to 5, like positive 5. And if I multiply those two same numbers, they will give me a product of 6. And then I told you guys, if you remember, is that you start off by finding the factors of 6. So what are the factors, or rather like multiples of 6? Well, I know that 6 is like 1 times 6 gives me 6, right? So can you do something? Can you like negate the numbers, or kind of like make each one the opposite sign to make them add to 5? Is that possible?
Yeah.
How can you make them add to 5 with some modifications?
6 minus 1.
6
Oh,
minus
6 negative 1. Yeah.
Yeah, so 6 minus 1 is the same thing, like if you do it that way.
But
So 6 minus 1 gives you, say what? I was about to tell you that. So 6 minus 1, actually that does give you 5. However, 6 times 1, that is not positive 6. 6 times 1 is actually negative 6. So that is not equal to positive 6. So which is why you cannot use that. Okay? So you can use 1 and 6. So now you ask yourself, what is another pair of multiples of 6? 2 times 3 gives me 6. So then if I add 2 and 3, what do I get? I get 5. And if I multiply 2 and 3, like I just said, they give me a product of 6. So, right? So then my two factors of this trinomial is supposed to be x plus 3 and x plus 2. Those are my two factors when I factored this trinomial. So then once you do that, you are done with the first rational expression, right? In other words, you are done with the first fraction. And now you move on to the next fraction. So then your next fraction is minus 5 over x plus 2. So it's actually given in a nice form where you don't have to factor the top or the bottom. So it is given to you in a nice form. So once you do that, what is your next step should be? Because again, this is like one of those rational expressions that you are being asked to simplify, but they do not have the same denominator. So you have to make sure that they do have the same denominator. And what is the thing that I should be doing to make sure that they have the same denominator?
Multiply.
Right. So you see how for the first denominator, you have two I would say like pairs of like binomials. So you have like 1, 2, and then those are like two binomials. So you kind of like have two factors for the first one when you factor the denominator. However, for the second one, you only have one. You have only one binomial. So there is something missing in the second one that you should be multiplying that with. So then that will make it have the same denominator as this one. What should you multiply the denominator of this with so that it will have the same denominator as the first one?
X plus 2.
Yes, thank you. And then the same thing, if you do something to the denominator, you have to do the same thing to the numerator, because we do not actually want to change the fraction. So if I'm doing that, then now if you take a look at the fractions that you have at the top, what do they have? They have the exact same denominators. So then I'm going to bring down the denominators in non-factored form, this is like in non-simplified form. So I kept them in the factored form. I'm not going to simplify them for now. And whatever you have in the top, you bring that down. And now here's the thing. You bring this down as well. So do you guys see that before the, like I did not put a parenthesis in front of the 5. Like I don't have to do it because it's a number. So as long as you don't have like so this number is going to be distributed, but then I don't really have to put a parenthesis before the 5 to encapsulate it. You guys will see why I don't have to do it. I mean, if you guys want, then you guys can like put like brackets in there, but I don't prefer doing that. So what I'm going to do is that I'm going to simplify the top. And how do I simplify the top? Well, I have parentheses at the top, right? So I have to distribute the 5. It's not 5, it's actually negative 5. So I have to distribute the negative 5 into our first term, and again, distribute the negative 5 into our second term. So x minus 2, what is negative 5 times x? Negative 5 times x is negative 5x, and negative 5 times positive 2 gives you negative 10. Right? Because a positive number times a negative number gives you a negative number. I mean, bear with me for a second, and I'll get back to you. So you have that at the top, and you have this at the bottom. So now if you take a look at your top, I mean, it's still not simplified. You still have to simplify it. And then at this very step, the way you simplify this is by combining the like terms. Those are your like terms. And remember, a like term is like a number which is, I mean, a term which has the exact same variable with the exact same exponent. You have to have the same variable and the same exponent. So now when you do that, if you combine x minus 5x actually gives you negative 4x, because 1 minus 5 is negative 4, and then x comes down like that, and then you have negative 2 minus 10 gives you negative 12. And then at the bottom, you have x plus 3, x plus 2, right? And now, if you take a look at this, what do you see, Maggie? Like, what do you observe? Kind of like, what is the first thing that comes to your mind? Is this the final answer?
To me?
Yeah, like, what?
Yeah,
like, does it look?
Yeah, it kind of looks right.
Right. So it kind of looks like it's in the right path. It kind of looks like it almost is a final answer, but it's not really the final answer. Well, the reason as to why it's not the final answer is because you are asked to leave your answer in the simplified form. So when you take a look at the fraction, you should immediately be able to say, oh, the fraction cannot be simplified any further. So if you take a look at the stage where we are in, can this fraction be simplified any further? Take a look at the top. And then compare that with one of the factors that you have in the bottom, and then you ask yourself, can I simplify this fraction anymore?
Oh, wait, GCF.
Yep, thank you, Maggie. I'm so happy right now. Okay, yeah, so you were able to identify that you can factor the top, and then the way that you should be factoring the top is by using GCF. So what is the GCF now? That's a tricky question. What is the GCF of negative 4x? So what is the GCF of negative 4x and negative 12? The negative 12 doesn't really matter if it's positive or negative, but then what is your GCF of negative 4x and then rather 12? I'll write that at the top. So the GCF, what is this supposed to be, Maggie? You want a little help? So the way that I'm gonna try to like help you is by telling you this. The GCF is gonna be a negative number. Why is the GCF gonna be a negative number? Well, the GCF is gonna be a negative number because the leading coefficient is negative. The 4 that you have is your leading coefficient that is negative, right? So if the leading coefficient is negative, that means your GCF is gonna be negative. So now you just simply use our old school way of finding a GCF. So you ask yourself, what is the GCF of 4 and 12? What is the greatest common number that divides 4 and 12 evenly? Well, the greatest common number, or the greatest number that divides 4 and 12 evenly is nothing but 4. And my GCF cannot have a variable to it because not all the terms in here have a variable as their common term, right? So if you do not, my apologies, not a common term, but then not as a common factor. As long as like not all the terms have the same common factor, you cannot factor that out, or you cannot have that as part of your GCF. So you have to have something. If you're trying to make it part of your GCF, you have to have that thing as something that all the terms have. Well, the 12 doesn't have an x, so my GCF cannot have an x. So it's just going to be negative 4. Amina, I recommend that you private message that answer to Meherin. Meherin, that's the answer for the last problem on the do now. So try to check if she did that correctly or not. So I have that, right? So now negative 4 is my GCF. Once you find your GCF, what are you supposed to do as your next step? You are supposed to divide each of the terms using the GCF. So my first term is negative 4x. And if I divide negative 4x using negative 4, I should be left with what, Maggie? X, right? I should just be left with x. And negative 12 divided by negative 4 is positive 3, right?
Yeah.
Thank you for confirming that. And now when you take a look at this, what do you see?
X plus 3 should be crossed out.
Yep, because that is actually a common factor. So you take them out, you cancel them out because you have the exact same thing in the top and also at the bottom. So then you should just be left with whatever you are left with, you multiply that across. So -4 times, you don't have anything in there, so it's really 1. So -4 times 1 is -4. At the bottom, you just have x plus 2. You don't have to put a parenthesis in there. So that is actually your final answer. So it's -4 over x plus 2. That is your final answer. Do you have any questions, Maggie? Do you want me to go over any of the steps that I did in here?
No, I got it. Thank you.
So then we are going to go back to our do now. So for the third problem, try the third problem on our do now practice list, Maggie, and then try to like private message me the answer.
Okay.
Amina, for the last one, you have the correct denominator. However, the numerators are kind of like off, I would say, from the correct answer. So try that one last time, or probably one more time. And I'm actually so sorry because you probably worked so hard for the problem and you didn't want it to be wrong, but you know, just practice is gonna make you better. So the more you practice, the better you get. So while Amina is working on the fourth problem, Maggie is working on the third problem. And private message me the answers. You can also put in the public chat. It doesn't really matter. And please, please, please ask me for help. Ask Mehreen for help. Ask us for help if you are stuck, confused, or need some help, clarification, anything. that is the correct numerator, Amina. And you also had the correct denominator, so combined, you got the correct answer. Let's go over the third one, Maggie. Yep, that was the correct answer to the fourth one, Amina. Great job. Super proud of you. Yep, so this was this is actually your third problem. And so this problem actually looks easy to me just because, you know, you have the same denominators, which is the most pleasant thing ever. But just to make things a little more exciting, we have different signs in here. So yeah, what should the first thing that you should be doing, Maggie, in here to simplify?
Multiply everything on a numerator.
So you want to multiply the numerators, but you don't actually have to multiply the numerators. Since you have the same denominators, you can combine them. So what I'm going to do is that I'm going to bring my first numerator in here. So x plus x squared, actually, plus 5x plus 1, right? That was the numerator of my first problem. So I'm done with the first fraction. Now let's work with the second problem. And what should I be doing with the second numerator before I bring that down? Like while I'm bringing it down, what should I do to that problem? Or like that numerator rather.
Change the sign before 5.
Yep, so I should be changing the sign, and I told you guys to put that in a parenthesis if you want. So if the only time you kind of like encapsulate something in a parenthesis is if you have a negative sign before it, because when you see the parentheses, you kind of have to, it automatically comes to your mind that you have to distribute whatever is outside of the parentheses into every single term that is inside the parentheses. But sometimes if you don't have the parentheses, you kind of forget to like distribute that into every single term you have. So that's why it's kind of like better to use parentheses. So then for the third one, the third numerator, I'm just going to bring it down like that. Once I do that, I simplify. And the first thing that I would want to do is that I want to get rid of the parentheses that we created there. So there's a negative 1 in here, right? So negative 1 times positive 4 gives you positive 4x. Gives you negative 4x, and negative 1 times negative 5 gives you positive 5, right? So then I'm going to write the rest of the part like it is. Right, so once you do that, you should be looking for your like terms. And what are the like terms that you see in here? X squared. Do you see any other terms that is raised to the second power that have the variable x? No. So x squared, it is gonna just stay in there. Now let's look for the terms that have x in them. So I see 5x, I see negative 4x, I see positive 7x. So I saw 3 of them. Now let's look for just constants. In other words, like just numbers. You have 1, you have 5, you have 9. So, okay, yeah, so when you identify them, now what is your job with them? You combine them, right? So that was actually the first step, or like the primary step to combining. So now you actually combine them. X squared does not have like a sibling. It's just going to stay by itself, lonely. So we have 5x minus 4x plus 7x. What is 5 minus 4 plus 7?
8.
Positive 8x. Right? So once you do that, you look at the numbers that you just have without any variables. So the green boxes, you have 1, you have 5, you have 9. All of them are being added. And what is 1 plus 5 plus 9?
15.
Yes. Thank you, Maggie. So when you do that, you look at this expression in here. And now you ask yourself, I have a trinomial at the top and I have a binomial at the bottom. So whatever you have in here, Maggie, what does it look like? Does it look like a simplified fraction? I asked you the exact same question before and it was a tricky question, right? So can you simplify this fraction any further, or is that the final answer?
Yes, you can. Factor the numerator.
You can. So if you take a look, how can you factor the top? There is only one type of factoring that you can apply to the top to factor it, and what is that?
It's 3 multiplied with 5, and you just add them, right? I forgot the name.
Trinomial factoring.
Yeah,
yep.
yeah.
So the way you factor a trinomial is by using nothing but trinomial factoring. So you should be asking yourself, what are the two numbers that if I add, they should add to 8, and if I multiply the exact same numbers, I should get 15.
3 and 5.
Positive 3 and 5.
Thank you, Amina, and thank you, Maggie. Yes, because 5 plus 3 gives you 8. 5 times 3 gives you positive 15, which is what we were looking for. Once you do that, you write the denominator, and now look at something fancy. What do you guys see, or what stands out?
X plus 3.
Yep, you have common factors. And what do you do with common factors? You cancel them. So let's cancel the common factors. Whoop, whoop. And you're just left with what?
X plus 5.
Which is your final answer. And x plus 5 cannot be simplified anymore just because x is a variable and 5 is a number. So that is your final answer. Any question, Maggie? Or Amino?
No.
No, thank you for participating. Clear. So now I'm not gonna go back to our do now again. What I'm gonna do is that let's work on the last problem and end it there, and then we're gonna move on with today's lesson. Okay, so for this problem, it is actually 3 fractions, but it not only has like different signs in between. So like for example, the first one is like a subtraction sign followed by a plus sign, but also has like different denominators. So the first, second, and the third denominator, none of them look alike. So in order for them to work our way through to make them look alike, we have to do something to them before we do that. There are actually like a couple of steps before we actually can conclude or like can make them look like they have the same denominators. And excuse me, the first step that I should be doing is factoring. I should be factoring all 3 of the denominators to kind of like identify what I should be doing or how I should be making the common factor denominators. So the denominator of the first one is actually x squared minus 4. And this actually is a special form of factoring. And the reason as to why this is special is because you have x squared and 4, and they're being subtracted from each other. And x squared, that is already a perfect square because it is raised to the second power, right? So that is a perfect square, check. The second one, 4, that is also a perfect square because 2 to the second power or 2 squared gives me 4. And when you have two perfect squares subtracted from each other, you can write them as using the as applying the rule for dots. So for dots, we originally had a squared minus b squared. Notice how both of them are squares, and then you can write that as a plus b and then a minus b, right? And once you do that, you should be able to see how this works out. So let's apply this into our type of factoring that we are trying to do with different kind of like terms. So we have x squared minus 4, which I literally told you guys can be rewritten as x squared minus 2 squared. So then in here, my a is my x, and my b is actually my 2, right? So then a plus b should be x plus 2, and a minus b should be x minus 2, right? And those are your two factors of this expression, right? And once you factor that, you write that in here. So it was x plus 2, x minus 2. Right? And once you kind of figure that out, you're partially, you're like kind of done with your first fraction. You move on to the second fraction, and the first thing that you should be looking at is the denominator. What kind of polynomial does the denominator have? Yeah, what kind of polynomial does the denominator have?
Trinomial.
Yep, and how do you factor a trinomial?
Using GCF.
You factor trinomial using trinomial factoring. GCF cannot work in here because the three terms that you have in there, they don't have anything in common other than a factor of 1, which is not really your GCF. So we're gonna try to do trinomial factoring. So then the way you do trinomial factoring is that you come up with two numbers that will add to -3. So two numbers that will add to -3 and two numbers that will multiply to +2. And what are the two numbers that? Say it.
It's -3 and -1. Sorry, no, -2 and -1.
Yep, so -2 plus -1 gives you -3. Because remember, when you are adding two negative numbers, you add the number and you just keep the negative sign. So -2 plus, which is like also, it can also be said as like -2 minus 1. It's like -3, and -2 times 1 gives you +2. Remember, a negative times a negative always gives you a positive product. So then I write that as my 2 as a factor. So then my first one is going to have -2. Once you do that, you are supposed to move on to the third denominator, or in this case, that is our last one. So the last factor, not the factor, but the last denominator is the same denominator, not the same, but that it's written in the same way like we had our previous denominator written. It's written in a trinomial form, right? The 3 terms, it's a trinomial. And what kind of factoring should we be using like we just did?
Trinomial factoring.
Yep, we should be using trinomial factoring in here. So then now we should be asking ourselves, well then what are the two numbers that will add to +1? And if I multiply those two same numbers, I should get -2.
-1 and +2.
So -1 plus 2 actually does give us +1, because the positive number, the greater number is a positive sign, your result is going to have a positive sign. And -1 times 2 gives you -2, because positive times negative gives you negative. So I'm going to write that as my factor. And whatever I had in the top, I'm just going to bring that down. And when we're done doing that, we did this entire process of factoring the denominator just to figure out how should we be creating the common factors. So now let's work on that.
Common denominator?
Yeah, common denominator. Sorry, I said common factor. I apologize for that. So you take a look at the first denominator and then you ask yourself, what should you be multiplying this with? So that this denominator has everything that the rest of the denominators have. So the way you kind of like figure that out is that you don't take a look at this denominator anymore. You take a look at this one and this one, and you try to figure out what is that thing that this thing does not have, and then that the rest of these two have. So then let's take a look at that.
X minus 1?
Yep. So x minus 1, right? So I take a look at x plus 2. Well, yeah, I mean, this one, it has x plus 2. So check. I mean, sorry, x minus 2, right? So this one does have x minus 2, so check. And then x minus 1, well, this one doesn't have x minus 1. So I should probably be writing x minus 1. And whatever I multiply the denominator with, I should multiply the numerator with the same thing. Now we take a look at this denominator. It has x minus 1, which now this denominator has because I just multiplied that with that, and has x plus 2, which this denominator has as well. So now it has all the components that the other ones have. And now we are good to go with the first one. And now you do the exact same process with the rest of the denominators or the fractions that you have in there. So my second fraction was this. Right, and then what should I be multiplying the denominator of this one with? So that it has everything that the rest of the denominators have. So I take a look.
2.
X plus 2. So in other words, you can take a look at the other denominators, and then now you don't look at the one that you're working with. You don't look at this middle one anymore. So you essentially take a look at this one and this one. So this one has x plus 2, x minus 2. Well, it has x plus 2, x minus 2. So check. This one has x minus 1, x plus 2. It has x minus 1, x plus 2. So check. It has everything that the other two denominators have. So now we move on to working with the third one. So the third fraction is actually that. Right, and then I have the numerator, which in this case is a binomial. But either ways, what should I be multiplying that fraction with so that it has the denominator as the rest of the fractions have? So you don't take a look at this one. So you do not take a look at that fraction. You take a look at the denominator, so the rest of the other two fractions. So in here you have x plus 2, x minus 2. You have x plus 2, there is no x minus 2, so you should be multiplying this one with x minus 2, the top and the bottom. We double check that using the middle fractions, it has x minus 2, x minus 1, x minus 2, x minus 1, so check. Now, after doing all those scavenging for common denominators and how to create them, guess what you have actually created?
Common denominator?
Yep, because all of your fractions now have the exact same denominator. And when you have that, you can bring the denominators down. So x plus 2, it does not matter which order you write them in. So that and x minus 1. And now you have to multiply across your numerators. So this one right there, and then we have this one in here. Last but not least, we have that one in there. So we multiply them across. So 2x times x minus 1. I'm going to simplify in the next step. But for now, I'm just like bringing them down. And then this is -1 times x plus 2. And you have plus x plus 1. Notice how I put this binomial into parentheses, because this is being multiplied with this one. And if you do not put parentheses, so if you write it like that, then looks like you just have to multiply the 1. You just have to distribute the 1. You do not have to distribute the x, which is totally different from putting parentheses around, right? But when I'm like multiplying across like that, I'm multiplying the entire binomial to the other binomial. So please keep that in mind, the parentheses and no parentheses way of doing things when it comes to multiplying. Once I do that, I have to do what? I have to distribute. So let's distribute 2x. So we're gonna distribute 2x into x and then -1. So 2x times x gives me 2x squared. Yep. And then 2x times -1 gives me -2x. This is -1. Please keep that in mind, that you're multiplying or you're distributing the -1 into x and 2. So that is going to change the sign. -1 times x gives you -x. -1 times +2 gives you -2. And in this one, the last part right in here, you kind of have to do FOIL. So in that way, you have to multiply x times x, and then you have to multiply x times -2. So x times x gives me x squared, right? And x times -2 gives me -2x. And now I multiply the 1 with x, and I multiply 1 with -2. 1 times x gives me x. 1 times -2 gives me -2. Right? And once you do that, you have simplified the top. Now you bring down your denominator. So that's your denominator in there. Now, when you are done doing that, what is the next step you're supposed to do? You are supposed to combine the like terms. And what are your like terms? Oh. So your like term is 2x. That's your first like term. And then I see another x squared in there. And that should be another like term. So I see this one and I see this one. Those two are like terms. And let's find another pairs of like terms. I see -2x, right? And I also see another -2x. And then I see +x, right? And I also see another -x in there, right? So many coefficients of x. When you are done identifying that, you try to find pairs of like terms that between the terms that you're left with. I see -2 and -2. Right, so now that we have color coded them, let's try to like combine them. So 2x squared plus x squared gives you what? 3x squared. Yep, thank you. And then negative 2x minus x minus 2x plus x. What do all those terms combined give you?
Negative 4x.
And why did she say that? She said that because if you take a look, negative x, positive x, that can be canceled out. Because they're exactly the same terms, but just with different signs. So when you, it's like trying to like tell you x minus x is what? It's 0. If you are trying to subtract something from itself, it always winds up in 0. So then then x cancel out, so negative 2x minus 2x is negative 4x. And I'm now left with the blue ones. So negative 2 minus 2 gives you what? Negative 4, right? And then I write my denominator in there. Like it was in there, and that is the answer. Even though the top in here is actually, it's actually a trinomial. So the top in here, even though that's a trinomial, it cannot be factored any further. So like not all the trinomials are factorable using the trinomial factoring method. That's a prime one, so it cannot be factored, which is why this one is your final answer, because it cannot be factored any further. Which is this thing right here, rational equations. So we were just working with rational expressions, right? And now we are going to go on to rational equations. And we will try to like solve them, right? And how do you solve rational equations? So we are just going to go no, it's not harder. It's actually easier. So the thing is, rational equations, you have one rational expression, or like you have some rational expressions before the equal sign, and probably some rational expressions, or just a fraction on the other side. So you can have like rational expressions on both the sides of your equal sign, or you cannot just have you know, just one of the sides might not have any like rational expressions. It can just have like a fraction with only numbers. So the thing that we are going to go into is that, okay, so in so you will see like rational expressions coming back and forth in like rational equations. So the difference between an equation and an expression is the fact that an equation actually has what it sounds like, equal sign, right? It sounds like equal equations. So an equation is going to have an equal sign, whereas an expression is not going to have an equal sign. That is actually the main difference between them. So far, we have just been working with expressions where we did not have any equal signs in the expressions, right? So now we are going to work with equations. And how do you solve rational equations? I have some steps listed in here, but it gets like much more comprehensive, I would say, if you do it using an example. So the first step, like we have been doing with rational expression, you factor the denominator, you find the least common denominator like we just did for our previous problem, then you multiply each side of the equation using the least common denominator, and after you do that, you're supposed to solve the equation. And the way you solve that is by multiplying. You do cross multiplication, right? So far we have been doing, we did multiplying across, so like cross, we did across like this, right? Kind of like horizontally, but now we are going to do diagonally, so like a cross, just like a cross. So, and then after that you solve your equation, and then you have your answer. However, something important to keep in mind is the fact that extraneous solution, it is a very common thing, and this is something that you should be always looking out when you do rational equations and when you solve them, because sometimes you might end up with answers that are not valid. What? Like answers that are not valid? Yeah, sometimes the solutions that if you plug it back into the original problem, it is not going to give you the same answer on both sides of the equal sign, and then that is not gonna work. So you should always go back and check for extraneous solution. Another way to identify an extraneous solution is that it is a solution that is going to make your denominator 0. And you cannot have a 0, or you cannot make your denominator 0, because then that is going to make your problem undefined, right? You cannot, because you use your calculator, see it, that if you try to divide something by 0, it's undefined. So you should always be on the lookout for extraneous solutions for those two reasons, because if the solution makes your denominator 0, it cannot be part of your actual solution. That is a solution, but that is not a valid one. That is an invalid one. And it can always, like, another type of scenario is that sometimes if you plug it back in, it does not give you the same result on both sides of your equal sign. And if you do not have the same result on both sides of your equal sign, you cannot have that as part of your solution. So we're gonna do this like easy problems. And then we're probably gonna call it a day from that. But these are like actually examples of rational equations. So you have a rational expression. So you have like a denominator, and then a numerator, which makes it a fraction. And on the other hand, on the equal sign, like I was saying, you may or may not have another rational expression. So for this one, it's just a number. It's not like another rational expression. Sometimes you have this. Sometimes you have like a number with a variable. Sometimes you have like not the rational expression. It really depends. But then you're gonna have at least one of the rational expressions on one side of the equal sign. And again, rational expressions are like ratios or like fractions which have a variable in the denominator. So try to like solve for k in the first problem. So for the first problem, I'm asking you to solve for k. And the second one, I'm asking you to solve for x. So I'm asking you, what is the value of k for the first problem, and what is the value of x in the second problem? And for this one, you do not actually have to factor the top or the bottom. What you can do is like you can cross multiply. And then you can solve. That is correct for the first one, Amina. So for this one, what you can actually do is like cross multiply. This 5 actually has a denominator of 1, so you like cross multiply. That is correct, Maggie. So what you guys did is that you cross multiplied, so 2x times 5 is equal to 3 times 1. I'm not going to write that down. And 2 times 5 is 10. And there was the k, so 10k is equal to 3. So k is essentially 3 over 10, which can also be written as 0.3. So now remember that extraneous root that I was talking about, or extraneous solution that I was talking about. If you plug back 0.3 into your solution, so what I was actually saying is that 3 divided by 2 times 0.3, that is actually 5. Try the second problem. Amina, for the second one, you cannot have x in the answer. You were supposed to find the value of x. So what is x equal to? That's what I was like asking you for.
Okay. I'm not sure how to do the second one.
All right, so for the second one, we do the same thing like we did for the first one. We cross multiply, or we at least start off by cross multiplying. So the 7 has a denominator of 1, right? So I multiply this. So I multiply 7 with this, and then I multiply that with the 1 that the 7 has as the denominator. So then 7 times x plus 4 is equal to 1 times, so I'm not going to write the 1. So it's like x squared minus 2. And now you're supposed to distribute. So you simplify this set of your equation. 7 times x is 7x plus 7 for 28. 7 times 4, 28. And then you have x squared minus 2. Now you have x all over the place. You have 1 in here, not 1, but like 2, x to the second power. And then you have x in here too. To solve for a variable, you have to make sure that you bring the variable to one side. So that all the variables, or at least the variable that you are trying to solve for, you have to make sure that it is all of them, they're on the same side. So I'm going to bring all the x's on the same side, regardless of what their power or exponent is. So what I'm going to do is that I'm going to subtract 7x from both this. I'm going to subtract 7x from both sides. So this cancel out. Now I have 28 is equal to x squared minus 7x minus 2. So now once you do that, you should be looking at this equation that you just created. And now what is the first thing that comes to your mind? Well, the first thing that comes to my mind is the fact that I can do trinomial factoring to this part. But right now I can't really do it because it's equal to 28. So what I will try to do is that I will try to make this entire equation equal to 0. And what should I do to make it equal to 0? Well, I should be subtracting 28 on both the sides. Because what happens when I do that?
That it will be 0 both sides.
It's not going to be 0 on both sides, but one of the sides is going to be 0 on this side. It's going to be 28 minus 28 is 0 is equal to x squared minus 7x. What is negative 2 minus 28?
Negative 30.
Negative 30. And once you do that, you're supposed to do what? You're supposed to do trinomial factoring. And how do you do trinomial factoring? Right, so you should be looking.
Negative 3, negative 10.
Negative 3, negative 10. Does negative 3 minus
negative
10 does
10 positive 3, sorry.
Negative 10 positive 3. So 3 minus 10, actually that does give you negative 7, and 3 times 10 is negative 30, which is right there, the two numbers that we were looking for. Once you do that, what you are supposed to do is that you are supposed to set each of these ones equal to 0.
Oh my god.
So I'm going to set this one equal to 0. And now, how do you solve for that? You add 10 to both the sides, right? Because you're trying to get rid of this 10. So then x is equal to 10. And then you set this part equal to 0. So in order for you to get rid of the 3, you have to subtract 3. And then subtract 3. So then x is equal to negative 3. So you essentially got 2 answers. Now what are you supposed to do?
Plug that in.
Yep, and check for
which one actually gave us 7?
Which one is, yep, and then if you have an extraneous solution. What do you mean?
The first one. That looks pretty good.
What do you, mean by 2.10, or is it like 210? Maggie, I'm sorry, I lost it. I didn't see it when you texted me.
Yeah, 210.
As the two solutions?
I'm kind of confused about why are we making everything 0?
Because for you to solve for something, you have to make sure that you have, so I'll get back to you on that later. But okay, I just want to check if we have if both the solutions are actually the solutions. So 10 squared. So 10 squared minus 2 over 10 plus 4, is that equal to 7 or not? We have to check. So let's check. That is equal to 7, so that is correct. That is one of your solutions. So 10 is actually your solution. And then you have -3. That is also correct. So what I just did was like -3 squared minus 2 over -3 plus 4. That actually does give you 7. So check and check. So going back to you, Amina, you asked me, why do you have to make it equal to 0? Because the only way you can actually solve for x when it is actually, sometimes you can solve it when it is like equal to a number. So what I tried to do in here, so when I was in, so at first when you are trying to solve for any variable, you should make sure that you have all the variables that you are trying to solve for, you have that on one side. So like, let's say you are trying to solve for y, you should have all the y's on one side. Because if you do not, if you have them spread, like if you have them dispersed all around, there is no way you can ever be able to solve for it. So you should always make sure that you have them on one side. So I brought.
Okay.
No,
you say it. Okay. So let's simply set the 0 equal to x squared minus 7x minus 30, right? And we write that.
So you wanna do x squared minus 7x is equal to 30?
No. I'm saying that this one, we make it equal to 0, right? 0 equal. Okay, wait. Give me a minute.
You can actually annotate on my screen, I think.
Okay, can you see this thing here? This line?
Where did you draw a line? Oh, the purple one. Yeah.
Yeah. So 0 equal x squared minus 7x minus 30, right? So we make it equal to 0. So if we put the x equal 10, that's the answer we got. So if we put 10 and then 10 squared minus, and if we like put 10 on x, would it be equal to 0?
It should. At any point in the equation, if you plug in the results that you got, it should be equal to whatever is on the other side of the equation. So it should give you the correct answer.
Yeah, got it.
But then the reason as to why I recommend not doing that is because what if you made a mistake in here? What if you did not do that step correctly? Then you are never going to get the correct answer. So like, let's say even if you got, I don't know how can you get the correct answer if you did this wrong, but let's say you did somehow end up getting the correct answer. So you like, let's say you got 10, but you did this step like incorrectly. So instead of writing 7x, you probably wrote like 6x, and you still somehow end up getting 10. I don't know how you did, but you got 10. So now if you plug back in that 10 into this step, it's never gonna give you, it's gonna tell you, oh, that is not the correct answer. But if you plug in this 10 into this equation, which is your original equation, you should know that that is your answer. That's why it's always recommended that you plug back your answer into your original equation, because you never know, you might make some mistake in your steps. And then even though you have the correct answer, which is somehow irrational. But even if you have the correct answer, you'll never be able to state that
Oh
as your
no,
correct
I was
answer.
asking because this 0 equal this whole thing, it was not looking like right to me, so that's why I asked. I got it.
Oh, that actually does give you 0. Look, I mean, I you made me like double check that. Yeah, if you plug in 10, so 10 squared minus 70 minus 30, so minus 70 minus 30 is like what? That's 100 minus 100, and then 100 minus 100 is 0. So
Yeah.
there you go. It checks off. So that's what I was like trying to tell. Like, if at any point you want to plug in your results, you should get that as your you should be able to validate that. But it's always recommended that you plug it back into your original equation and see if it makes sense. So this side should be equal to your other side.
Yeah, so for this kind of problem, we always make things equal to 0.
Well, I mean, so the reason as to why I made this one equal to 0, because I knew that it was it was a trinomial factoring. And for trinomial factoring, when you should always like set it equal to 0, because if you don't, then when you come here, it's gonna be like equal to 28. And you know how you were able to like solve for x easily in here because it was 0? In here, you have to like subtract that from 28. And it gets a little messy. So it's always recommended that you make one of the sides equal to 0, and then you make all the other things go to the other side. For this one, I was able to see that it was a trinomial factoring, so then I had to make the other side equal to 0. It's only gonna make sense when we do more practice problems, when we do more similar problems. So yeah, any questions with whatever we did today? I mean, these are obviously not the easiest kind of like, I would say, algebraic problems, but these are part of the algebraic problem. So, you know, sooner or later, you would have to like encounter these crazy ones. So yeah. Do you guys have any questions with anything we did today? Anything you want me to go over? No, we good? So Amina has no question with smiley face. Maggie, do you have any questions or any points of confusion? Like you need probably some clarification. Please, please, please ask me. I'll try to help you as much as I can.
Okay.
You're good? Do you have any questions?
No.
Okay.